We're going to be looking at the Edexcel FP2 question on the Maclaurin series from June 2011, question 2. This question gives us the differential equation for d2y by dx squared, and we've got to find an expression for d3y by dx cubed, identifying the value of the constant k. Then, given the conditions x equals 0, y equals 1, dy by dx equals 2, we've got to find a series solution for y in ascending powers up to and including the x cubed term. The first part of this question, we're given d2y by dx squared, and we need to differentiate it using a product rule to find d3y by dx cubed. So, we need to have a very clear method since the answer is given. So I'm going to let u equal e to the x and v equal the bracket term d2y dy by dx plus y squared plus 1. du by dx is clearly e to the x, and dv by dx is going to require a little bit more skill, since to find dv by dx I need to also differentiate that product. So I'm going to differentiate that product by inspection without introducing more variables. So to differentiate that product, I'm going to differentiate the 2y with respect to x times leave the other term plus leave the 2y times differentiate dy by dx with respect to x will be d2y by dx squared. Now I'm going to differentiate y squared with respect to x, so that will be implicitly 2y times dy by dx. When I differentiate 1, I'm going to get 0. So now I can bring all this together in my product rule to get d3y by dx cubed is du by dx times v, and take your time copying this out, making sure you don't make any little slips, plus u times dv by dx. And tidy it up a little bit, there's a dy by dx squared there as I'm going along. And now if I take the e to the x out as a common factor and see what we are left with, just bring it all together now. And we should be able to collect like terms and double check that we've got exactly the required solution. Okay, so I can see the 2y times d2y by dx squared. I can see 2 dy by dx squared. And if we look in there, I can see 4y dy by dx. There's 2 dy by dx, and another 2 dy by dx is 4y dy by dx. And then I can see the y squared plus 1. Y squared plus 1. K is a constant to be found, so I can see k is the coefficient of y dy by dx, So K is 4. The mark scheme for this part of the question had a method mark for applying the product rule. It had an accuracy mark for applying the product rule successfully, and an accuracy mark for the final answer, and K equals 4. So in this part of the question, we're going to use the given initial conditions and the given third derivative, d3y by dx squared, in order to produce the series solution for y in ascending powers of x, stopping at the x cubed term. So we know that we're given that when x is 0, we know that y is 1, and we know dy by dx is 2. I can use the given formula for d2y by dx squared, which would give me e to the 0, 2 times 1 times 2, plus 1 squared plus 1. So I know the second derivative is exactly 6. I can also use the derived formula for d3y by dx cubed using the given information. So I know x is 0, y is 1, dy by dx is 2, and d2y by dx squared is 6. So this will give me e to the 0, 2 times 6, plus 2 times 2 squared, plus 4 times 2, plus 1, plus 1, gives me the third derivative is exactly 30. Then I can quote the result that my series for y is going to be y0 plus x times the gradient when x is 0 plus x squared over 2 factorial, the second derivative when x is 0, and finally x cubed over 3 factorial, the third derivative when x is 0. So y is approximately 1 plus x times the gradient, the initial gradient, so that's 2 times x, plus x squared over 2 factorial times the second derivative, which is 6, plus x cubed over 3 factorial times the third derivative, which is 30. So y is approximately 1 plus 2x plus 2 factorial is of course 2, so 6 over 2 is 3x squared. 3 factorial is 6, so 30 over 6 is 5x cubed. And there is my final answer. The mark scheme for this part of the question gives a B1 mark for the examiner seeing that the second derivative is 6, another B1 mark for writing that the third derivative is 30, a method mark for correctly using the power series formula for y, and an accuracy mark for the final answer. The final accuracy mark is a follow-through mark following on from any initial mistake with the B1 or the second B1. You can get further guidance from the Further Mathematics Support Programme. Their website is at www.furthermathematics.org.uk.